This meeting is now being recorded.
Okay, good afternoon, ladies and gentlemen. It is time to start. Welcome to the Office of Information Management and Analysis Brown Bag Series. The webinar will be strictly a 30 minutes event for both presentation and questions and answers. Title of today's talk is Using Adjuvants to Improve Weed Control Performance and Provide Better Environment Stewardship. The presenter is Jim Glasshofer. Jim Glasshofer, Bachelor of Science degree in Chemistry from Case Western Reserve University, Cleveland, Ohio. He has 42 years of formulation experience in the research and development of agricultural products, including pesticides, adjuvants, and biologicals. Jim has worked as a senior formulation chemist for Wilbur Ellis Company for the past 10 years. He currently manages Wilbur Ellis Product Development Laboratory located in Fresno, California. He is responsible for the development, commercialization, and technical support of adjuvant products line sold by Wilbur Ellis. With this brief introduction, I will pass the presentation to you. Go ahead. Thank you for coming and doing this for us.
You're welcome. Thank you for inviting me.
Yeah.
So, in this presentation, I'm going to be covering these 5 points. Why adjuvants need to be used, what they can do, why they're needed. We're going to review 5 different types or classes of adjuvants and how those choices are made, and we're going to include some of the new technology advances in the area. We're also going to be talking about good steward practices and how you can get optimal weed control by using adjuvants. And we're going to review the regulatory status of adjuvant chemistry, both in the U.S. and worldwide, briefly touching on it. And then we're going to discuss adjuvant performance criteria that's applicable for use in and around waterways, since that's what we're really talking about here. I'm going to use as a model here what is actually done for aquatic weed spraying of water hyacinths. And so here you see a boat that goes into the pads, can get through the thick water hyacinth cover. The operator is spraying the pads through a wand, a spray wand. And this is another view, and you can see how bad of a problem this is, where the whole waterway is basically clogged up. And then he has to basically treat a large area. Particularly want to highlight the water hyacinth plant here, which is in the right side picture, because it has a very waxy leaf surface that tilts downward. And so as this person is spraying, some of that material can run off into the water and not stay on the water hyacinth, which is undesirable. And adjuvants can play a part in that. So why do you use an adjuvant? Well, an adjuvant is used with a pesticide or agricultural spray product to increase the efficacy, the biological activity, or to modify the physical properties of a spray solution. So you can change the surface tension, the pH, and there are a bunch of other parameters that we'll go through here. One thing that is sort of a myth about using herbicides and pesticides is that they typically are not formulated for adjuvancy, for the best possible activity. They're formulated to have the highest possible concentration and the best stability in the container. And then it's left for the adjuvants to supply or supplement the adjuvant characteristics to get the optimal delivery to the target. And that's true in your case, for the case I showed there, where they use unloaded or glyphosate that has no adjuvant in it, because most of the adjuvants would not be allowed from an aquatic toxicity standpoint, the usual things that are used with glyphosate. The benefits of using a high-quality adjuvant are many. First of all, you can increase the herbicide penetration and its activity, that's called activation, and then optimize the efficacy of the amount of material you're putting out. You can reduce droplet bounce and increase the deposition on the leaf. So you basically are spraying it, you want it to stay where it sprays. You can increase the spreading and wetting characteristics of the droplet once it's on the target, and that's particularly needed on waxy or hairy surfaces where it's difficult to get the herbicide to the surface. And you can also control drift and reduce off-target impact. So those are some of the benefits of a high-quality adjuvant. There are 5 different types of adjuvants that I've listed here that are appropriate for the model of spraying on water hyacinth. The first class are called surfactants, or referred to as NISs, or non-ionic surfactants. They provide wetting, spreading, penetration, and activation. They're the most commonly used for glyphosate use. Oils can also be used, and they increase penetration and activation and can improve uptake. They contain some surfactants, but usually those surfactants are designed to be emulsifiers to help the oil to mix in the water. And you have to have that characteristic, otherwise you won't be able to deliver the adjuvant to the leaf surface. One form of adjuvants that isn't well known for, probably for this area, are water quality products. With glyphosate is subject to mineral antagonism, and so you would use a water quality product to stop that or reduce that effect, to shift the pH into the correct range to get the best performance, and to increase the uptake. So we'll talk a little bit more about water quality products. Then there's drift reduction technology and deposition aids, which stop the drift from occurring off target and provide sticking and retention on the target surface. And the 5th one we won't cover very much, but they're problem solvers, such as defoamers, pH adjusters, and compatibility aids. So those would be the 5 types of adjuvants you could possibly use. There are many things that influence activity. You can see them all here. You have to balance all these things to make the proper choice and to control the factors that you can control. So just going around this wheel here for water hyacinth, well, you control the pesticide. You probably have to adjust the water quality for your target. We know what the target pest is, the water hyacinth with a very waxy structure. You're going to be subject to the weather. You don't want your product to wash off or to be spraying when the wind is blowing quite a bit and blow it off target. Then there are other concerns and off-target risks and the type of equipment that you use. So all of those things influence efficacy and what type of pesticide and adjuvant you would use. First, we're going to talk about drift control. Well, the benefits of controlling drift off of a spray situation is that there's less product moving to off-target locations and more product retained and sticking to the target. The moving off target would be the drift. Staying on the target is typically classified as deposition. And drift control products can optimize the droplet size, the number of droplets that you're getting per unit area, and increase the coverage. And we're going to see some examples of that in the following slides. And that's what they do. So what is drift? What does it look like? Well, this is a worst case scenario here where a farmer is using an air blast sprayer in his orchard, and he's trying to blow his liquid into the tree canopy, and you can see here a lot of it is just going up into the air. A considerable amount of what he's spraying is not getting to his target. In a normal spraying situation in agriculture, you would have something that looks like this slide. And drift is very difficult to see, so there's more drift going on here than it actually looks like. Drift is defined as being anywhere between 105 micron and 150 micron droplets or less. So smaller than 150 certainly would be subject to drift or off-target movement by the wind, shear forces, etc. So again, going back to our water hyacinth spraying, you see that the user here is trying to moderate drift. He's using a very coarse spray, it looks like there, to coat the water hyacinth, which is good. There probably is still a little bit of drift happening here. Drift control products, however, can be very effective and can help you select your spraying system. So this is an example of a nozzle and pressure setup where no drift control agent is being used, and you can see the cloud of drift happening, and that could be herbicide going everywhere you don't intend it and drifting perhaps even yards or a longer way away. And then if you add a drift control product at 1 ounce per 100 gallons, you can see that you have a much better effect, and this particular one is labeled for aquatic use. So it could be used around aquatic organisms. There's deposition aids that often come with the drift control products. You get better deposition. This provides more even, uniform droplets, better ballistics, more complete coverage. You have fewer small droplets that drift away from the target, so you get better deposition of all the pesticide you're spraying and paying for. And you have the ability to tailor the droplet size and distribution for the application equipment you're using, the nozzles, the pressures, and the wind conditions that you might be under.
Sorry to interrupt you. I don't think your next slide is showing. I'm still seeing the drift control. Okay, here we go. There we go.
Okay, maybe loading slowly.
Yeah, might have.
Yep.
Is that what they use?
So this is an example of good deposition. You see here where you have the deposition aid used, the droplets are smaller and they're more uniform, as if you're painting the surface. And you wouldn't want to get areas that aren't covered very well or where the droplets coalesce. So this is another good advantage of a drift control agent, that it supplies this kind of uniform droplets and deposition. This is an example of deposition of a spray droplet. So you saw here that the droplet impinges on the leaf surface. Now we're going to see that as a blow up here. And you can see it's almost like the droplet is magnetically attracted to the leaf surface. And that's what a good drift and deposition aid will do for you. Very valuable. And in the water hyacinth sprays, you're going to want those coarse droplets to stick to the waxy water hyacinth. Bounce is what you get if you don't use an adjuvant. And it would be very undesirable in this case. So this would be an example of bounce, where there's no surface tension reduction of the droplet hits the surface, and the thing acts as if it's a tennis ball. It will just bounce and roll, and may even roll off a waxy surface like the water hyacinth into the water. Rather, what you're trying to do is get it to splat and stick, and then rapidly spread to coat the leaf surface to start the activity going for the herbicidal activity to kill the plant. And so that's what you're achieving with an adjuvant. That spreading is very important. Adjuvants need to supply the right amount of spreading, and you can do that with the choice and with the concentration of the adjuvant. You can also wet too much. Organosilicones, for instance, are adjuvants that are super wetters, and in this case might help the material to actually roll off or sheet off the leaf surface, which would be undesirable. This is an example in this video of spreading when you don't have a surfactant or surface tension reduction present. You see that the droplet pretty much dried in place. Oops. I'm going to have to go back. And then if you have a surfactant, you see it's covering a much wider area of the leaf surface, so you're getting a better area covered, and it's also starting to penetrate into the pores and surfaces and cracks and crevices of the leaf surface. That leaf surface is very important, and with water hyacinth, you have a very waxy surface, but you can also have hairy leaf surfaces, which are much more prevalent than people think, or a smooth surface or a corrugated surface. So we're going to specifically focus in on a waxy surface, which is fibrils like this that are waxy. If you look at the surface of wheat, it has a corrugated surface without very many hairs on it, would be what that surface would be like that you coat on. Corn, you would think, might be like water hyacinth. It's actually a very hairy surface leaf that has a lot of hairs. And if you have a lot of hairs on the surface, you can stick your droplet up to the top and it never will strike the surface. So If it doesn't strike the surface, it won't be active. Rather, you want the adjuvant with the surfactant to wet through the leaf surface to get to the plant surface where it can then be absorbed. And I believe water hyacinth would act more like sugarcane here with its wet surface, where just like with your car when it's waxed, the water will beat up on it. The water beating up is bad because if it coalesces, you'll make a big droplet. It could run right off the plant. Also, you haven't spread over the whole surface. You can see that there's a lot of surface that isn't covered here. And I believe water hyacinth looks a lot like this. For water conditioning, you can see here that on the map that the area around this area where you treat the Sacramento River Basin has slightly hard to moderately hard water. That would call for glyphosate having a water conditioner in it, typically if this were for normal agriculture. And there's a magic recipe that shows how glyphosate interacts with various minerals in the water. This is a recipe that will help you calculate how much ammonium sulfate you would use if you could use it. And you see here that iron would take the most to try to offset the antagonism, or iron in the water really hurts glyphosate control. So you'd want to try to mitigate that, and the most common mitigation is ammonium sulfate. Ammonium sulfate, unfortunately, is very toxic to aquatic organisms and fish. So there may be a threshold level, or it may be something you just can't use, but it's commonly used in the agricultural area to boost glyphosate activity. Typically, you would call for this area about 1.5 to 3 pounds of ammonium sulfate. There is a possibility to have other types of water conditioners, but that would have to be explored to do the same thing to see which could be aquatically usable. AMS and other water conditioners can provide additional benefits, such as acting as humectant, assisting in diffusion, and acting as a foliar fertilizer to help the plant acquire the pesticide. The most common thing that you're going to use for water hyacinth control is penetration and activation coming from an adjuvant. And you're primarily getting that by helping the spreading and the chemistry actually helping the pesticide to penetrate into the leaf surface. This is typically done with highly concentrated non-ionic surfactants called NISs is the buzzword for it, or emulsified oil adjuvants, crop oil concentrates, which usually contain petroleum oil, and methylated seed oil or ethylated seed oil, which are based on soybean oil typically, or canola oil. They're designed to optimize and promote diffusion and absorption into the leaf, so they'll take and drag the pesticide in with them into the leaf surface, where it can then do the weed control that you want it to do. They also tend to reduce the surface tension to improve coverage and spreading, and they're excellent for most herbicidal uses, including the glyphosate you would use on water hyacinths. What you're doing here is you're trying to get the glyphosate through the waxy cuticle of the leaf. So rather than sitting on top, you're trying to get it to absorb in and go into the pore structure of the leaf, where it can go in and actually somewhat dissolve the leaf wax and do some other things depending on the structure of the plant. However, modern adjuvancy really is focused on the diffusion mechanism. So this is kind of a busy slide. I don't want you to reflect on this too much, but what formulators try to do now is they try to match the surfactant in the adjuvant to this specific pesticide and have the diffusion coefficient be equal to the driving force down through the leaf. So if the adjuvant components and the pesticide diffuse into the leaf surface at the same rate, that gives you the best adjuvancy. And a lot of formulations are being used and improved using this knowledge to really help it. So we've talked about the benefits of the adjuvants: drift control, deposition, droplet adherence, the ability to reach the target, and improving spreading and uptake. So you would choose your target in this way For water hyacinth is the weed. You're using glyphosate as the herbicide. Glyphosate requires it to go into the herbicide to go into the plant surface. So you'd be picking an adjuvant that would focus on deposition and penetration. And in all applications, generally, this one included, improved deposition on the target is always a benefit. Different adjuvants with glyphosate perform differently. You can see here, this is a graph of activity on velvet leaf, which is a hairy leaf structure. And you can see with the circled product with no or little adjuvant that this is actually glyphosate at a reduced rate. You see you've got almost no kill or no control. But by adding various additives that are found in adjuvants and different adjuvant formulations, you see you can get a wide variety of activity and a 4-fold boost. I've seen as much as a 10-fold boost, depending on what you're doing and what the conditions are. So adjuvants really can boost your performance at a cost-effective level because they're typically used at a very low use rate compared to the pesticide. So we see that they're not all alike. And then this is a slide to show old technology versus new technology. So this is an old nonylphenol ethoxylate NIS, weed field that reduced glyphosate use, and a new product called Rainier EA, or some of the new adjuvant technology. And you can see, even though this was R11 was an old workhorse, the new product works as well or better under the same circumstances. And so there is new adjuvant technology to come to bear here. Going back to our situation here, we're going to talk about stewardship real briefly. The good stewardship practices can be achieved with adjuvants because you have this goal of reducing the off-target chemical impact. So you'd want the safest possible biodegradable chemicals and adjuvants that have the least aquatic organism impact. And there's new options here. Before, there weren't too many things that you could use in an organic or aquatic environment. You also want to reduce the impact and amount of off-target chemical applied. So in the case of water hyacinths, you wouldn't want to have it in the air, and you don't want it getting into the water. You want to stay on the water hyacinth. You can also minimize human exposure hazards and unintended exposure toxicology effects. So you can do that first by mitigating the drift, that you don't get exposure of a breathing product, and you can use products that have low SDS hazards and don't contain nonylphenol ethoxylate. So that's to reduce the off-target chemical impact. Now, you also have the goal to provide the best on-target weed control performance. So you would want to use the lowest but labeled herbicide rate that you can use to get good performance by using the best performing adjuvants. The combination gives you your goal. You can also reduce potential for weed resistance. I don't know whether water hyacinth is becoming resistant or not, but in the environment, one would say it's just a matter of time, basically, where it's going to be more difficult to control water hyacinth with glyphosate. You can also optimize these materials for your specific application system. And that would, all these things can lead to better stewardship of the product and the application. Just quickly to look at two labels for different products. You're currently using Agridex or oil concentrates like our competitor product. That is the name competitor. And if you look here and you see, well, you'll see that this is a crop oil concentrate, Agridex. It has petroleum distillates in it, and it has a warning placard. So, and the use rate would be 1 to 4 pints per acre. If you look at an option that has now come onto the market that you would have here, this is Rainier EA. This is one of the new options that you might have here. You see that it has 88% surfactant, no oil, and it has no placard. So it doesn't have a warning according to the new GHS standards, which would typically be warning or danger. So this is a very safe product that can be used in aquatic environments and would be used at typically use rates lower than the 1 to 4 pints per acre of the Agridex as an option. You also note that it's registered in both California and Washington, whereas Agridex is only registered in California. Washington has tougher aquatic standards. The regulatory implications of adjuvants are many. They're banned in a bunch of places all over the world. They're banned specifically for products for use in agriculture in Europe. Canada and Central America are asking for voluntary removal, and there's regulatory pressure to remove them. In the U.S., there's no full EPA restrictions yet, but Washington State has aquatic limits where you cannot have more than 10% of a nonylphenol in your adjuvant and have a for aquatic use label. The biggest influence, though, is Walmart and Target. Walmart and Target have a policy of not selling products that contain nonylphenol ethoxylates. And that trickles down to the agricultural world, too, as food producers where they're worried about possible residue testing for nonylphenol ethoxylates. Nonylphenol ethoxylates, the basis for the restriction is that they are hormonal mimics. That chemistry class mimics the activity of hormones, which is undesirable. They used to call it endocrine disruption as well. Glyphosate and dicamba are requiring drift control and products to be pH buffered to a specific level. This has increased because of the regulatory concerns around drift of dicamba, which is an incredibly potent herbicide. More drift control products are being developed, and more water conditioners as well. So there may be an opportunity there because of that regulatory registration to have a better effect. Water quality legislation is limiting where you can apply different materials. It's requiring buffering zones around drainage areas and watershed areas, and the proper drift control, the proper adjuvant that it can be aquatically approved may mitigate some of those buffer zones. Last of all, for glyphosate, the most prominent and effective adjuvant for glyphosate, toluamine ethoxylates as a class, are under a lot of regulatory pressure as well and have very poor aquatic toxicology. What do you do to get a for aquatic use label? Well, currently, for an adjuvant, what you do is you do testing on Daphnia and rainbow trout fingerlings. And you would establish the no effect level and equilibrium constant or equilibrium concentration after 48 hours for Daphnia, and that has to be a value over 1 to pass. For rainbow trout, you have to have a value or concentration that is over 10 ppms, or that box figure to the right would be 10 milligrams per liter. As you can see, these set of adjuvants, which are now options for use in aquatic, are well above those thresholds. So this is the type of testing we do. To get for aquatic label, you have to pass both of them. So, and you can see that these three ones pass quite handily, which wouldn't be the case for lots of other classes of chemistry. So what you want for aquatic and water hyacinth control glyphosate, to me, is you want NPE or APE-free components, no nonylphenol ethoxylates. You want the products that you use to have for aquatic use labeling, to be safe in aquatic environments. You want to have improved formulations for eye toxicity and worker safety, so they should have the lowest possible warnings and caution statements on the label. And then you want, for all those other good benefits, you want equal to or better than weed control. For the products to be as efficacious or more efficacious than the previous products. And Wilbur Ellis has a whole product line now called Eco Advantage that does this. It's short for eco-friendly and has those 4 criterion. So those are your new options that you have, and other suppliers will be creating these things as well. So finally, for a straw man evaluation of your real problem with water hyacinth, there are some considerations as I looked at the problem. First of all, the glyphosate that you use is labeled for aquatic use and will have no adjuvants in it. So you definitely need the best possible adjuvancy and probably a higher level than you would if you used actual formulated glyphosate instead of the unformulated glyphosate. The current oil adjuvants that you use, Agrinex as a COC, our competitor product, are most likely not the optimal products for glyphosate control. Nobody in the typical agricultural world uses an oil with glyphosate. What they would use and what you would predict would be the best case would be to use a high-performance NIS surfactant, some sort of drift and deposition aid, and some water conditioning. Now, the water conditioning would be the most difficult because typically the water conditioning chemistry is pretty toxic to in the aquatic environment. Then you would want to optimize the rates of these things for your aquatic spectrum and the equipment that you're going to use. So the rates would let you tailor it specifically for your problem. With that, I'm going to conclude because I'm over time, and if there's any time for questions, I'll field those.
Okay, people on the phone, we will unmute you now. If you have questions, please speak up.
All guests have been unmuted.
If you have questions, you can ask. Thank you. Any questions? Is there any questions from the box? Any question for Jim? Okay, I think we will adjourn with this. We don't have much questions. So
Great presentation.
Yeah. Thank you for coming and
Thank you.
present this one. Thank you all for participating. Okay, we adjourn. You have a minute? No. Okay. Thanks.
The host has left the meeting. So at this time, the meeting will come to an end. Thank you and goodbye.